Okay, good morning. So we talked about the complex plane last time. So it was idea was simple, but it becomes very powerful sometimes in solving problems. You can use your geometrical intuition to solve to conclude something about complex numbers. So in principle, it is just simply I have two coordinate axes here. The only difference is that one of them, the horizontal one, is not called the x-axis. It's called the real axis, and this vertical one is called the imaginary axis. And they are, as usual, perpendicular, and when they intersect, it's called the origin. And the only thing that you need to remember is that a complex number z, which is a plus bi, which is an abstract notion, it's a number, but now can be viewed as a point on the complex plane. More or less the same thing. So this A plays the role of the x coordinate. There is no x coordinate, of course, here. The real part, you have it, for example, here, and the imaginary part, you have it here, assuming that A is positive, B is positive in this case. And then you will find a point. This is a point that in this setup represents that complex number. Okay, and then we interpreted what we had before as transformations or some geometrical properties of this. One of the important ones was the absolute value of z, which can be interpreted as the distance from the point associated with the complex number z to the origin. So if you want to visualize what is the meaning of this abstract number, it is the distance from that point to the origin. Yes, this is the interpretation. And one important thing is that what is the interpretation of this? If z and w are two complex numbers, what was the interpretation of this? Of course, one interpretation is that z minus w is a complex number. It is somewhere on the plane, and then absolute value, according to what I just told you, is still the distance from that point to the origin. This is of course true, but it is not that useful. The useful interpretation was, you remember?
Distance between z and w.
Yes, so z and w are 2 points on the complex plane. It is better to interpret this as the distance between 2 points z and w on the complex plane. This is more powerful interpretation. Okay? And I started solving some problems for you. Those are important problems. Let me add more and wait for you to solve, and then we continue. So this is the continuation of that example. I don't know how many we solved, 9 or something, but let us start from scratch again. So we can say that specify, let me use a different language, specify the set of all points. Sets here means collection. Specify the set of all points. Specify the set of all complex numbers z on the complex plane such that, so number one, 2z plus 3z bar is equal to 5. And number two, 3 times z bar plus imaginary of z plus 3z is greater than or equal to 1 minus 2 real parts of z minus 2. Okay, I wait for you to do this. So let me tell you something. In the previous examples, I don't know how many we had before, mainly my concern was geometrical interpretation. But I think in the last example, if you remember, we also solved it using algebraic method. So let us consider this is the continuation of that example. So my emphasis here will be on algebraic calculations. Of course, if you can find a way to interpret these things geometrically, be my guest. I didn't have any clue about it. Okay, so I would say that as a guide, use geometrical approach to understand this. Okay, any progress? So what about this one? Any figure or any shape? Yes.
Shape the answer.
Yeah, just give me an answer. What shape this represents? Is there any particular shape for this set of points? Because you remember we had strips, lines, I don't know, annulus, circles, discs.
1 coordinate.
1 point. That's correct. So it only represents 1 point. It's a little bit weird, but it just represents 1 point. So this is what I expect you to know. So if you want to solve that, so you need to remember. So for example, you need to understand which method is more useful here. Of course, geometrical idea is not very helpful here because we don't know how to interpret them geometrically. So what we do, we just write it algebraically. So for the first one, I would say let z be equal to x plus yi. Yes? And I told you it is better when you want to solve these kinds of problems instead of writing a plus bi, write x plus yi because it naturally interprets as the x-axis and y-axis. Okay, so, and then you put it here in this equation. So what is the equation? The equation is 2z plus 3z bar is equal to what? 5. I put this here, so it becomes 2. Instead of z, I put x plus yi. Instead of z bar, what should I write? Z bar is the conjugate of this. So the real part repeats itself. The imaginary part becomes that. And on the right-hand side, I have 5. Yes? And I will try to simplify it. Let us just do it in one go. If I multiply this by 2, I will have a 2x from here. If I multiply this by 3, I will have a 3x from there. If I combine them, it becomes 5x. Again, if I multiply here, I will have 2yi. If I multiply this there, it becomes minus 3yi. So in total, it becomes minus yi. Yes? And on the right-hand side, I have 5. So this is the first session lesson on complex numbers. The left-hand side is a complex number in a standard form. Yes? This is the real part. This is the imaginary part. The right-hand side is also a complex number in a standard form. Not exactly, but you can imagine that this is 5 plus 0i. And now I have one complex number in a standard form equals to another complex number in a standard form. This cannot happen unless the real parts and imaginary parts are correspondingly the same. So this means that 5x should be 5 minus y should be 0. And then what do I get? I get x is 1, y is 0, nothing more. So it means that if this complex number is supposed to satisfy in this equation, there's one chance for it. X has to be 1, y has to be 0, and that is one single point. Yes? So if I ask you to represent that, so you just draw this coordinate system, the real axis, the imaginary axis, x is 1, y is 0, this is your point. Yes, is that right? Did you get the same answer, Melvin? Yes? Okay. But what about this one? Could you manage to do this? Okay, so if I have designed this question, hopefully I did, you should be a little bit sensitive to this symbol. Because I told you that the notion of order is lost among complex numbers, unless by accident it is designed in a way that I is gone somehow. Because if I is left, then I will be in trouble because I cannot compare a complex number another complex number to say which one is greater than the other one. Okay, so did you do calculations? Yes?
Like the dotted line on 5/8 and then everything past that.
Yes. So it is a half a plane, you are saying.
Yes.
One side of a line.
It's just like a dotted
That is my impression. Let us see if I haven't messed up here. Because if one of these numbers is changed a little bit, then I will be in trouble. Then it cannot be interpreted at all. Okay? So hopefully I haven't done that mistake. So, but again, I start with the same sentence because this is hard for me to understand it geometrically. There is only one way for me to solve it, and that is algebraically. Yes? So what we do, I would write that sentence if this is the problem. So let me start from scratch. So I would say let z be equal to x plus yi, and I put it here. So 3 is 3. What is z bar? Z bar is x minus yi. And then I have imaginary of z, which is, what should I write instead of imaginary z? Only y, be careful. Yes, and then plus 3 times your z is greater than or equal to 1 minus 2 real part of z, which is x plus yi minus 2. Yes? I just put them there. That is, yes.
Wait, the real part is just x.
No, the real part of this combination. Yes? So it means that because the pair of brackets prioritize subtraction. Always pair of brackets prioritize an operation. So you just do this and then it becomes a number, take the real part of that resultant number, yes? So here, there is nothing here, I have to multiply. So this becomes 3x minus 3yi plus 3y. Then I multiply this here, so it is 3x plus 3y. Okay, so we are on the safe side because this I is gone. Okay. And then here, what should I write? Greater than or equal to 1 minus. Here, if I ask you what is the real part of this number, what do you say? X minus 2, because this is not still in a standard form. If I want to write in a standard form, these two should be combined together as one real part and then yx. And then if I ask you what the real part is, this is the real part. And then I have a minus 2. Is that right? Okay, then let us simplify. So fortunately, this interloper is gone, yes? So 3x plus 3x is 6x, and then I have 3y. And then here I have greater than or equal to 1 minus 2x plus 4, yes? Yes, of course, how do you want to interpret it? For example, if you don't want, let me move this to the other side, because usually if this is equality, we keep y on the left and then move everything to the right. Let us pretend that this is equality. So 3y is greater than or equal. Minus 6x minus 2x is minus 8x. And then 1 plus 4 is just 5, yes? And then I divide everything by 3, it becomes this one. Okay, so far actually you got most of the points, of course. But then you have to interpret this geometrically. If it was equality, it was very simple, because that's a line whose slope is this, and its y-intercept is that. Yes? But here I have inequality. So if I have inequality, so it means that this line is the border, and then you need to see that which side of this line is represented by this inequality. So the first thing that you do is just draw the border. So, for example, how should we draw the border? So I don't know. For example, let me just draw the border here. Y is equal to minus 8 over 3x plus 5 over 3. For example, because I know this is a line, 2 points is enough. 2 points are enough for me. So x and y. And then I put 0. I get 5 over 3. I don't know. I put, for example, y equal to 0. If I put y equal to 0, it means that 8 over 3x is 5 over 3. So x becomes 5/8, for example. Yes, something like that. And then I try to find those points. So don't be concerned about these numbers. This is just drawing a line, yes? So x0, y 5/3. So let us pretend that this is 5/3. And then x 5/8, which should be smaller than that. So this, let us pretend that is 5/8. And then 0. So these are the points. So I connect them. This becomes a line. If it was equality, that is it. But it is not equality, it is inequality. I am interested in those areas for which y coordinate is greater than that. Yes? On this line, y coordinates are equal to this. But I want to have y coordinates larger than those. So which part of this line do you think it will be acceptable?
The right side.
The right side here. If you doubt about it, this is a good way to do it. For example, you know that the origin is here, and the coordinates of the origin are 0 and 0. Put that coordinates here. What happens? It becomes 0 greater than or equal to 0 plus 5/3. But this is a false inequality. So it means that that side that contains origin cannot fit here. So then it means it is the other side. If you can visualize it, better. But if not, so you have to draw it. So if you want to give a feeling what that is, so you need to say, I mean, you can just color it. Something like that. Or you can just write 2 arrows. So it means that this is continuing forever from this side. Anyway, my goal is not to sketch it perfectly fine. I want you to have a feeling what is represented by that inequality. Is that right? Okay. So let me solve 2 different problems now, which can come in the national exam, and then probably we can solve some problems from the national exam. So this is example. So let z be a complex number such that what was that? The absolute value of 1/2 z minus 3i, absolute value is equal to 2. What are the maximum and minimum of absolute value of z? Okay, so you start working on it. I will write a similar problem, but harder, okay? So you start working on this. So the questions as English sentences are identical, but I have just changed the equation from this equation to that equation. Yes? So I want to give you a little bit of time to think about the problems. So here it is important to have a geometrical understanding of what these equations mean. When you have your answer, please let me know. Yes?
The first one I got, the minimum is 2 and the maximum is 10.
Okay, so what is your interpretation?
I pulled 1/2 out of the absolute value, and then I got z minus 6i equals to 4. So then I got
Mm-hmm.
so it's a solid circle.
Yes.
Centered on
Okay.
0.
But don't they tell me the details, yes? You have a circle, then?
Yeah, and then I took the bottom of the circle is a distance 2 from the origo.
Okay.
The top of the circle.
Okay. So you interpret it geometrically. That's correct way of doing it. So that's very good. Thank you. So, first of all, I want you to have. So you have to have experience about this. So in that example, 1/2 z minus 3i is equal to 2. Can I multiply everything by 2? Why I need to, first of all, why should I multiply by 2? Why I'm thinking about multiplication by 2? Because I have this standard interpretation. If I want to have this interpretation, I have to have a minus sign between, and I want to have z with coefficient 1. So that's the motivation, first of all, why I want to get rid of this 1/2. Okay, so let me just do it systematically, but you can do it faster. In principle, you have to factor a 1/2 out because you want to get rid of this. Then this becomes z, but this becomes minus 6i, yes? Equals to 2. Why is that? If I multiply back, this is correct. If I multiply that, that's correct. So that factorization is correct. But then we had a formula for the absolute value of z times w is what? Absolute value of the first one, absolute value of the second one. So then this means this multiplied by that absolute value, it becomes absolute value of the first one times the absolute value of the second one is equal to 2. But absolute value of 2 is what? Absolute value of 1/2 is just 1/2. And that is 2. And then I multiply by 2. It becomes 4. So in principle, you could multiply by 2, but you need to understand if that theorem was not true, multiplication by 2 was not applicable here. So there is a difference between absolute value and a pair of brackets. But in this case, it doesn't matter because we have that theorem. I want you to understand at least. Okay, anyway, so you get rid of it and write this, and this is a good one because that's exactly according to this interpretation that we just talked about in the beginning of the lesson. That is the distance between z and 6i, and the distance is supposed to be 4. So where is 6i? You can imagine that, for example, this is 6i, yes, 6 units up, okay, and the real part is 0, and I am interested in points z so that the distance from that point z to this fixed point 6i is 4 units. So that is a circle centered at here with radius 2, radius 4. Okay, so radius 4, if I go 4 units down, here it becomes 2i, yes? And then of course I have to go 4 units up, so this becomes 10i, yes? So I cannot draw that circle very fine, but this is 4 units, 4 units, 4 units, 4 units. So let us say that this becomes my circle. Something like that. Yes? You need to imagine that this is nothing except the points on that circle. Is that right? That's the meaning of that. So 4 units up, 4 units down because my radius is 4. 4 units to the right, 4 units to the left, and then try to sketch something. Okay? And then the question is asking you about what? About the maximum and minimum of absolute value z, but absolute value z has also a geometrical interpretation. What is that? It is the distance from the point z to the origin. So it means that on the one hand, I am restricted to be on this circle. On the other hand, I want to see what is the maximum distance to the origin if I am on this circle, and what is the minimum distance. So I don't want you to prove it rigorously, but intuitively you understand which one has the smallest distance. This point is the closest point to the origin, yes, and this point is the farthest point to the origin. Okay, so what is absolute value minimum? Is this distance 2? What is absolute value z maximum? It is 10. So it's a good question because you have to have a geometrical understanding. Okay. Might be you can also solve it algebraically. I didn't test because this is a good idea to have. It was not hard, by the way. You just need to interpret this as a circle. We had practiced about this a lot. And you also need to know what is the geometrical meaning of absolute value z. And then, of course, based on your geometrical intuition, you understand that this is the lowest distance, this is the smallest distance, and that's the biggest distance. Okay. But can we solve this problem geometrically? Algebraically. Let us try. I don't know. I don't know what will happen. Might be we will be in trouble. So if you want to solve the same problem algebraically, you would say let what z be equal to x plus yi. Yes? And then you plug that into the equation. So you don't need to simplify it anymore in this way because you want to solve it algebraically. So let us put it there. So this becomes absolute value of 1 over 2z minus 3i is equal to 2. Okay, algebraically it means that you need to do algebra. So this becomes 1 over 2x. The next one becomes 1 over 2y, I, but minus 3i. I combine them. It becomes 1 over 2y minus 3i equals to 2. Yes? Okay, and then the absolute value of this, you know what is that? It is the square root of the real part squared, which is 1 over 4x squared, the imaginary part squared, which is this one squared. Yes? And on the right hand side, you will have 2. Okay, so I raised both sides to power 2. This square root is gone. This becomes 1 over 4x squared. And I will also expand that. Okay, so what happens? It becomes the first one squared, 2 times the first one times the second one, and the second one squared. But remember, I raised to power 2 to get rid of a square root, so this is now 4. Okay, so let us multiply everything by 4 to get rid of this. It becomes x squared plus y squared. Yes, and then I move this to the other side, multiplied by 4, it becomes 12y. And then, of course, I multiply that by 4 as well. So it becomes 16 minus 36 is minus 20. Do you agree? This is what we get. So I multiplied everything by 4. It is minus 12. I move that to the other side. It is 36, and this is 16. I move this to the other side, it becomes minus 20. But is this combination familiar? So let me take this. Is this combination familiar? What is that? This is nothing except absolute value of z squared. Yes? So this becomes absolute value of z squared is equal to 12y minus 20. Okay, so can you read the maximum and minimum here? So if you want to maximize absolute value, because this one is equal to this, it means to maximize the right-hand side. Yes? My goal is to maximize this, and this means that I have to maximize this y. So it means that I have to go to the highest point on y. Yes? So what is the highest point on y? So you cannot solve it algebraically because then you need this picture as well. Okay, so that's the problem. So you see, if I ask you what is the highest value of y, then you can say the highest value of y is 10. But that is not useful because if you multiply that by 10, what happens? 120 minus 20, it becomes 100. So it take the square root, the maximum z becomes 10. So yes, the maximum z is 10, but of course I still use this. If you want to solve this algebraically, you need more tools in your hand to be able to maximize this. So this is why I'm saying that this is a good question because somehow it forces you to think geometrically, and there are some questions in the national exam, as we will see, that you have to think in that way. So at least I want you to understand that algebraic method works, but not fully independent of geometrical picture. If you want to solve it fully independent of geometrical picture, that will not be an easy problem for you, okay? So you can make the complete squares and things like that, it works, but it is not very useful. Any questions? Okay. So the next question is the same question, but harder. Okay, so do you have any idea what to do with that? Okay, let us just do it together because after that I want to solve some national exam problems about this topic so that I want to have more time. Okay, so let us start doing it together. So you will realize that forget about geometrical picture. So for this one it becomes even harder. So algebraic picture. Let us do it geometrically. Okay, for geometrically interpreting this problem, the first part is not hard. So can you see what is this or not? What shape is represented? What region, what shape, or in principle, what collection of points is represented by that equation? The equation is z minus 8 minus 8i equals to 5 square root of 2. Yes?
It's a solid circle with the center 8, and with the radius
Yes.
5 square root.
Yes, is that right? Because you have to write it in a standard form. A standard form for interpreting, there should be a minus sign between two complex numbers. So the first thing that you have to do is factor a minus sign out. Yes? And then equals to 5 square root of 2. It was not strange to factor a minus sign because I always interpret what I have with the standard pattern that I have in mind. Then if you compare this one with that one, of course z is the same z, minus sign is the same minus sign, and then you realize this plays the role of w. Yes? So this means the distance from z to w as usual. So the distance, w is a fixed point. Z is a variable point. But what I know about z, I know the distance from this variable point to the fixed point w is a fixed number. Again, it's a circle. But the circle is centered at this point, and the radius is this number. Yes? So let us try, I don't want to be precise, but let us try to sketch something. So 8 and 8. Let us pretend here is 8. Let us pretend here is 8. And then, of course, this becomes this point. That's my center. The radius is 5 square root of 2. Square root of 2 is approximately 1.4. If you multiply it by 5, it will be below 8. So if it is below 8, it will not intersect these axes. So it would be something like this. Yes. The radius is 5 square root of 2. Of course, it is important to realize it will not cut the axes, yes? Yes. Because 5 square root of 2 is less than this distance 8. So that is the picture. Of course, I have to do it with solid line because that is okay. This is my circle. The question is the same. I want to find the maximum of z and minimum of z, but this time instead of having z on that standard circle, I have it on this circle. Okay, what is your opinion about it? Let us see, anyone else?
8 plus 5 square root of 2.
No, how do you come with that conclusion? You have to have a good understanding. So, anyone else? Yes?
The absolute, we have to take the absolute value of w, and then for the minimum, we subtract 5 square root 2, and for the maximum, we add 5 square root 2.
Okay, so let me forget about this because I want to test if your understanding is correct. So if I have a circle here, yes, and I give you a point here, and I ask you which point on the circle is farthest to this point and which one is the closest one. And then I give you a ruler, for example, what do? Forget about this because that is the same problem. I have a circle and I have a point. I want to find the distance from the points on the circle to this single point. So I give you a circle. Of course, when I give you a circle, the center is clear, the radius is also clear. Okay, and I give you the ruler. What part you measure to find the closest one and what part you measure to find the farthest one?
Draw a line through the dots.
Exactly. So you draw this from this fixed point. You draw a line to the center of the circle. Yes? And then this line will intersect your circle at 2 points. I don't want to prove it, but intuitively we know. This is the smallest distance, and that this is the largest distance. Okay, so this you need to have this picture in mind if you want to find the distance, the maximum distance and minimum distance of the points on a circle to a point outside. Then you just take that point and connect it to the center and continue it. Then you will get to intersection points intuitively, just based on your intuition. This is the smallest one and that's the largest one. What do you think will happen if this point is inside? So this is my center, and this is a point inside. The same method will work, yes? So I will just connect them. Then I have 2 intersection points. This distance is the smallest one. This distance is the largest one. They have used this in the national exam, so have this idea in mind. Okay, so now here, if I want to find the shortest distance, I have to do the same thing. What does it mean? It means that I have to, because here I want to know the maximum and minimum of absolute value z. It means that this is the minimum and maximum of the points on the circle to the origin. I will do the same thing. So I will connect this. I will connect this to the center and continue it. I will get 2 intersection points. This is, according to that interpretation, this is the smallest absolute value z, and this one is the maximum absolute value z. So the interpretation is exactly the same. But the problem is, this problem is harder because you don't know how to calculate directly these things as the previous example. The previous example was just reading the information from the picture. But here, you cannot immediately read this information from the picture and that one. So you have to do some calculations. But is that understandable? So how should we do the calculations? I need to find this distance exactly, and I want to find this distance exactly. Can you tell me what to do? Let us wait a little bit. Yes?
Calculate the hypotenuse, and then you add.
No, the hypotenuse, I have this length, I agree with you, but then I still don't have that hypotenuse. Because this is not 8, be careful. So here I have this from here to here is 5 square root of 2. From here to here is 8. If you want to solve it geometrically, let me know what to do.
Oh, why don't you just a squared plus a squared and b?
So 8 squared from here and then 8 squared from there, it gives me this length.
Yes.
And then
Subtract.
subtract the radius. Simple as that. I mean, it was not immediately clear, so that's why it's a little bit harder problem. But you are right, because if I can measure this distance, yes, more or less I am done, because I am interested in this distance, but if I know the bigger distance, because I know this is the radius, I can take it off, then I am left with this, what I want. Exactly. So this is 8 units, and this is how much? 8 units again. So this hypotenuse, let me call it L. L squared becomes 8 squared plus 8 squared. So this becomes 62 times 64. So L becomes 8 square root of 2. Yes, so L is that one. So now, what is Z minimum? Z minimum is 8 square root of 2 minus 5 square root of 2, which is 3 square root of 2. Yes? And what is the largest distance now?
A square root
The Z maximum is equal to from here to here, but plus the radius. So this becomes 8 square root of 2 plus 5 square root of 2. It becomes 13 square root of 2.